Welcome, this is where nerds come to learn things. If it's your first time here, click on the subscribe button and on the bell icon to get notifications about new videos. Thanks for watching, hope you enjoy it. Okay, so these two electrolytics just here, I think that's the only ones on the board. And then we're done. Well, hopefully done. Polarities are marked, that's always nice. Let's try and get them out. And they're folded over as well, of course they are. Right. Voltage for those, 40 volt, some 63s here. I'll use these ones. It's only got the negative stripe opposite the markings. Try and see both. I must have forgot that. Oh, that pad lifted, that's not good. Still enough there though. Is that okay? I think so. So I'll keep you all happy, shall I? I'll get a anti-static brush. This one's actually a bit soft, I've got a harder one. This one's a bit too hard, that's the problem. Okay, set one done. Let's clean the other board up. We've got a wire to do yet too. I might just take it off and glue the bloody part down actually. So I'm going to leave this other bit where someone's done rework before. I'm going to leave those alone in case I need to go back to those to revisit them. So I'm not going to clean those bits off. Let's just glue this other part down and I'll take that wire out. No, it is out. That's a sleeving over the wire, great. Let's take the whole thing out. Actually now maybe I should have a throw and pull it. Actually, we will do it. It's in one place. Take it out. It's going to get hot quick. And I'll just let go of it. Now I lost it. And I'll touch the back of the LCD connector, the display there. Got any greasy fingerprints in there. Glue the capacitor down. Put it in there anyway, but it's going to do it anyway. One screw sitting there. Nice from there. There we go. I'm going to loosen this back off again now because that doesn't line up. Of course. Towards the last screw. Come again. Mind you, the chassis is slightly bent at the back here, I did notice that. It's probably affecting the alignment. Show the side. See, it's bent in. Like the back has been pulled or something. It's a bit strange. Didn't notice any obvious alignment issues though, apart from this circuit board here. So, if it matters or not, I don't know. It's actually pulling the board downwards. Don't like that. And when I power this up, I'll do it without the cover on in case something smokes. Right, let's check these caps. I wish it just defaulted it. Anyway, positive is one of them. I think positive was this side. So it's 4.5 microfarad or millifarad. So we're 4.6. So that's close to value, and ESR looked good, so that was probably right. Must change clips. So push jeweler in again. Yes, I should recalibrate, but I'm not going to bother. It's 1052 microfarad, 0.1 ohm, looks alright. I don't care if they'll test good, I want to replace them anyway. What have we got here? 1072 microfarad, 0.1 ohm. Also okay. .5 microfarad, 23 ohms. 23 ohms. That seems a bit high. I think that was no good. .1 microfarad, 17 ohms. Yeah, those two there were gone. And we've got this one here. So that's 226 UF, 0.2 ohms, that was alright still. And .250 UF, 0.3 ohms. So the fact the resistance is increased slightly and the capacitance is also increased slightly means this one's probably on the way out. Observation I've got is that the capacitance will increase as they start to fail, before they go completely wacky. So I think that one was starting to go anyway. So, all good. So, let's plug this thing back into power. Now this is going to be live in the series, so I have to make sure I don't touch it because otherwise I might get zapped. Don't do that. And get the road sorts going again. So feed in a signal. Oh, it's wonky because I didn't put it on properly. That wouldn't help either. Maybe it's just the fitting's wonky. It still looks straight. I don't know. Maybe that's slightly bent. So, power on there, click the switch, I need smoke. No smoke. First switch is still firing up, so we'll do channel B first. We want generator at, let's do 150 megahertz because no, that kind of works. And is that on? That is on. There's nothing there. I think this is working. It's not counting. How can it be worse? Oh, let's change it on. Change that side. Let's do 200 megahertz. Why is there nothing there? Have I missed something? Is something not plugged in properly? Because that should be working, I think. Let's just try a different piece of test gear. This one should have enough output power. This is off the Marconi doing 0 dBm input. 200 megahertz. There's nothing there. It's like it's not counting at all now. It's actually worse. That's 10 megahertz. Nothing there. That's not bloody good, is it? Okay, let's check for shorts across this transistor. See if there's anything there. It doesn't appear to be on it. That way around there is. But not that way. So it might be okay. 0.5. 0.5, those look right. Open. Open. That's charging something up. That transistor's okay. It's not that. Try a different approach. Must be careful with what I leave in my hands. So the base has got 6.9 volts on it, and this base has got 7.4. Collector's got 6 volts, 4.8 volts on that one, 6.4 volts on that one. Look at that jittering around. Is it jumping around? That looks interesting. It's 12 volt. Okay. So there's noise on the output of that one. Let's check there's noise on the input, I didn't notice that. So the base looks clean. The emitter looks clean. And so does the collector now. But the voltage is fluctuating. Is there a problem here with this chassis? I think so. Don't know. The voltage is definitely wrong. But why? Yeah, so one of the 5-volt rails is definitely missing. Well, not missing, it's wrong. This is to reference my reference voltage. Maybe that's what I'm doing wrong, referencing wrong. Could it be that? Well, so this op amp is what I'm suspecting right now. Because obviously this is a closed loop system, so the op amp should be outputting a voltage in order to drive this transistor, which will then drive the base of that transistor in order to regulate the voltage, right? So it's a closed loop voltage regulator. So the likelihood is it's one of these 4 components. And my history of op amps failing is quite good, as in I find a lot of bad op amps. So I'm leaning towards the op amp being bad. There's also this D24 which may have an effect. So I think I just need to check these individual components and see what we find. So TR20 we obviously know about. IC15, which I probably have some in stock, I will have to check. TLO84, so 184, 148, so I know I've definitely got them. Home resistors definitely got them, so D24, R112, let's find those parts. And we'll check them on the board. Hopefully from the back of the board we won't take it all apart. So I'll just get onto that. Okay, it's 100 ohms, that's working alright. Check diode. .6 that way, which you would expect. That way, oh, might be touching the probes together. Let's change them around. Measuring 0.5. Probably some circuitry around it. Of course, it's across that transistor, isn't it? So I'm going to get reading from the transistor. So it's not shorted, and it's probably working okay since it's got a ready both ways. So it's not that. Okay, now it's down a bit. I want to measure that bloody transistor that's there. I think it's those three there. That looks the same, so does that one. So I think that is the set of that transistor there. So we'll look at those ones and try and check this transistor as well. .6 open. 0.6. See, it's got a diode across there. 0.6 that way. Yes, I think that transistor's okay. So I'm leaning towards op amp now. Where is it? Got to find it now. But the fact it's not receiving any bloody signals now is also a concern. Maybe those tantalums are loading down the supply rail and protecting it. Maybe it's gone over voltage, and so now it's blown up. I wish that guy would fuck off. I wonder if I can measure that supply rail without this top board in. Might be possible. So I see 15 is right there, I can see it. It looks like someone's been soldering near that. There's no flux residue there. And there's an R104. Let's have a look at R104. Is that linked to it somehow? Just in case it's purely an alignment issue. So this R104 right here is adjustable resistor. So let's just look on the diagram and see where that comes up. In case it's linked to it somehow. So it's R104 over here, there we go. So that is adjusting, looks like the 12 volt rail. Yeah, 12 volt set. So that's what that's doing, and that's working. So that's unrelated. Well, I can get to that device. I suppose I could do some measurements on it and see if I can actually see what is going in and out makes sense or not. So yeah, we'll measure pin 1 as the output, obviously, pin 2 and 3. 3 is approximately an 8 volt input. So you've got, what's that, maybe 18 volt, 18k and a 24k there, voltage divider from the 12 volt rail, which you know is working, and that's going to pin 3, so I should be getting about 8 volts here. That can't be right, can it? Because pin 2 and 3 we try and do the same thing. Whatever the voltage is at pin 3, pin 2 should be the same, shouldn't it? So pin 1, 1 volt. Pin 2 is 5 volts. Pin 3 is 5 volts. What? That's correct. What? If pin 2 is 5 volts, then the 5-volt rail must be correct. What the hell's going on there? Yeah, pin 3 should be 5 volts, the same as the output rail, because it's doing comparison, isn't it? So it should be the same. So it is, and it's working. What? That's now confused me, because we definitely weren't getting the right voltage before. Is it the reference I'm using for the test point? 7.4, 8, 8, what? Am I missing something here? If the collector from that transistor, which is on the right side just off the screen, is going to pin 2 of that op amp, they should be the same voltage, shouldn't they? Right, so I'm going to clean this front panel switch just to be sure that that's not what's causing the problem with the channel A and B switching over. It is an open type switch. Yeah, they're quite commonly used switches, but spray a bit of cleaner in there and wiggle around a bit and see if it does any difference. It does feel quite loose. It doesn't feel like it's like a good snap action on it. Well, now I'm feeling it's got a little bit of there, but it's not as sharp an action as I'd like it to feel like. See if that does anything. I doubt it will, but there's no harm in doing it. But this board has got a whole bunch of issues with wires. Now this is an old, let's say this is a mid-80s kind of chassis, and well, early to mid-80s chassis, and this design, as I was saying before, but I forgot to record it. The wires on this, they aren't plated through holes. Normally, like on the modern PCBs, they drill a hole and they electrically, the chemical plating process, right? So it plates through the holes in the chemical process. Whereas these actually have like a little pin that goes through the hole in the board, which is then soldered on both sides. And that particular design is problematic. They do fail. You get a bad joint, and the actual solder pads are like domed and stuff like that, so they're actually soldered, but it actually break underneath the solder, so it'll look okay, but you won't even see it. The only way to fix it is to resolder the joints. And in fact, this is doing some weird things, and it's I had a failure where obviously when I redid the work on it, then it didn't work at all. When I found that to be a bad wire, or some bad wires, I'm not sure exactly which one, leading from IC15, which is the feedback and the control of the voltage regulator for one of the 5-volt rails. So there's actually a bad wire, a bad connection between those devices. Resoldering some of those wires fixed the problem, and it got the 5-volt rail back properly. But now it's got other problems with the channel. Well, previously channel A wasn't working, it's still not working. So I've done the repairs inside the box here for that. Whether there's still a problem in there or not, I don't know. But the fact that there's bad wires means I'm concerned that there's probably an issue on the main board with the wires themselves, and it could be that's what's wrong. There's signs of other people working on this previously. These wires here have been resoldered all around the place. It's like random ones which have been done already by someone. So it's like someone's already been trying to trace a fault on it. And I'm actually thinking I might just go over the whole board and resolder the whole thing and see if that fixes any problems. And if I put enough heat on one side, I might be able to get it to go right through without having to try and do both sides of the board. So yeah, it's a bit of a pain. And it looks like some of these might have been replaced already, these chips, because they're in sockets. I don't know, they might just be, they might just got 1979 that one, so probably not. Should look at the codes, that's 1982, soldered in. 79, 91, 74. Oh, sorry, it's part number. 75, 1975. That's an old one, that one. So lots of old parts in here, but I'm confident the power supply side's okay now because we've done all that. But I think there's bad wires and that's causing all kinds of problems. I think that's the next thing I need to do is to go through that process and just do that tedious work of resoldering every single joint on the board, because I think it needs it. Alright, so I've done some tracing around, and pin 11 on this jumper connection here, which is going to go to this main box, should be minus 12 volts on there, and there isn't. And I've traced that back through to this little jumper block here, which I'll show you a bit closer. And see there's a bridge between 4 and 5. That should be minus 12 volts on those pins, and there's nothing there. And back down here, TR23, TR24, just down there, which you can probably see the metal can next to the tantalum right there. That's the pass transistor. So there's a suspicion that maybe that's died because of the tantalums in the main box blowing, which has then shorted it out the rail and blown the pass transistor. That's most likely the scenario. So we're going to have a probe around and we'll see what we can find. The easy thing to check first is the input, to make sure the circuitry's got input voltage going to it. And I'll check that across this capacitor here, which is 190 replaced. If there's voltage there, DC voltage, then I know that it is a DC supply going to the regulator circuit. And then I'll just go probe around the pass transistor and see what we've got then. So it's pretty easy to diagnose that part. Now it is on. So if I just measure across here, which way around it is, what doesn't matter. So we have 18 volts DC at that capacitor. So the power supply going to that regulator is obviously there. So I just need to figure out the probing on the actual transistor to see what's going on there. I'm getting tangled up. C41 is right next to it. Just trying to determine which traces on here are the punts. I think that's it right there. I see 3 pads. Don't drop that. 3 pads right there. That looks like a transistor there. But there might not be the right one. There's 2 transistors side by side. It might be TR23, not TR24. Let's try and line that up. That is TR23. Okay, gotcha. So that's TR23. Those 3 here, TR24. So power is still on. Let's probe around, see what we find. So I'm going to go straight to TR24. So we've got the power going in there. So that's 18 volts. We have 9 volts on that pin. Nothing on that one. That pin there goes through to the other transistor, so that would be the base, which means the pass transistor has died. Right, I guess I'm going to have to figure out what I can replace it with. Right, so I'm going to take this transistor out, because it's obviously dead, and all these legs are bent over, so I'm just going to straighten them back up so I can get the thing out. Edge cam. Right. Nice, we have the pin out for this other device I'm going to put in there. There were heaps of these BD139s. It's got a massive upgrade, it should work. I'm really surprised if it doesn't. So let's see, pin out for this is faded. I can't read it. Hold on, where is it? It is ECB. So I'm going to collector base, and the original part is emitter base collector. So pin 1 is correct. I'm going to have to change around the other pin outs. So I need to swap some pins around. I'm going to have to try and spin the pins around in this orientation. Hopefully go through the holes. They're a little bit thicker. Feels like I'm going to go through the holes. That's good. Come on, get in there. Right, fingers crossed I got it all around. Let's just double check my thinking here. So emitter, that pin there goes through capacitors, that's correct. Collector middle pin, which is twisted around to the back, goes to the bottom, which goes out. Yep. And base, which is the right pin, is there. Yep, correct. Right, that should work. Obviously it's a bit of a bodge. Ideally you put the right part back in, but this should work. It's an upgrade. I'd say it's like a 90% chances of work. Right, current on that channel is set to what? 40 milliamps, that should be right. Wrong way around, doing negative supply. So we want that in there. It's doing 100 milliamps. Yep, 100 milliamp draw, so that should be fine. What do you reckon we put it back together? Okay. Signal source, which is my Marconi, set to 210 MHz still, at 0 dBm. You want that on that side, we do. Right. Leave the power off until I'm ready to test it. Over that way. I'm going to shove this probe in somewhere, it'd be really convenient. Right, voltage. Minus 12 volts. Right. Progress. Minus 12 volts on there. Excellent. That's correct now. Question is, do we have a signal? Seems the answer to that is still no. So 500 MHz going in. It's got a gate flashing. But it's still not going. So there's still a problem somewhere. Could still be a virus. I don't think I'm feeling any heat, so I don't think it's anything getting hot. This is frustrating. We keep finding problems and fixing them, but it's still not fixed. Right, so now I'm trying to diagnose this board here to see what's going on with the output of the channel A. Now this is the connector right here, and it's got 12 pins on it. Well, it's a 12 pin connector, but it doesn't actually have 12 pins. There's a couple of pins that aren't even there, or have no functions, no connections to them, that sort of stuff. So I'm probing around it, and pin 1 right there, that's doing 12 volts, positive 12 volts. Pin 12 is positive 5 volts when the switch on the front panel is set to channel A. Pin 11 is, pin 11's there. That is minus 12 volts. That's quite a critical one. 10 is doing nothing, that's 0 volts. 9 is doing nothing, that's 0 volts. 8 is doing nothing. Pin 7 is a square wave of about 7 volts peak to peak, interestingly, and a frequency of about 8.7 kilohertz. Oh, sorry, 8.7 hertz. And it's basically a timing of around, I have to get the cursor set up right, I might have to change my views on here actually so you can see what I'm doing, but the timing is 54 milliseconds. So there's 54 milliseconds on there right now. Apparently it can be anywhere between 50 and 100 milliseconds with no input on the front, so that's within the range of what it should be expecting. Pin 6, I've got some kind of waveform there, let's zoom in a bit, and that is a very jittery, well, it's a very variable frequency there, it's changing a lot. So it's basically a square wave, and it's changing between, well, it's pretty hard to say. It's fluctuating up and down quite a lot. It's around 330 kilohertz. Oh, sorry, 330 kilohertz or so. But it's also rapidly changing, so it's sweeping very quickly. So I can't just see exactly what it is, but it's jumping around significantly. Sometimes it's seeing as low as about 80 kilohertz. But it's sweeping up to at least 350. But yes, yeah, it's jumping around a lot. So I can't tell you exactly what it is, but it's about 6.2 volts peak to peak. So I need to actually go back and check on that manual and see what that says about it. That one there, 0 volts. So that's pin 5, pin 4, 0 volts. Pin 3, 0 volts. Pin 2 has got no connection, there's no pin there. Pin 1, so it's got that 12 volts on there. So I'm going to go through the manual and just double check some stuff. I know pin 7 looks correct. I'm just going to go and look at the other pins now. Okay, so apparently pin 4 is the VCO, which is supposed to sweep, and pin 4 is this one here, and that's doing nothing. So if I plug an input on there, there's no difference. There's nothing, no signal at all on the VCO output. There's nothing there. Pin 9 and 10 are supposed to be waveforms, and those are there, about 3.9 kilohertz or so. About 580 millivolts I'm getting. And they're supposed to be out of phase with each other, but I can't see that because I'm just doing single probing, but they both look correct from the waveform perspective. They're both the right frequency and the right amplitude. So it looks like the VCO signal is missing, and that should, I think it's supposed to go to a high state or low state if there's an input signal, but plugging an input in and out doesn't change anything. So it's definitely looking like there's an issue on this particular board here. Now this is one I repaired previously with all the tantalums which are blown right here. 3 tantalums which are gone. 2 of which were discoloured like this, and that had a big lump of solder on it. Right, that's all. You can probably see it in the light maybe, I don't know, but it's discoloured on the top. And one was turned to charcoal. So the charcoal one's actually on the positive 12 volt rail. The discoloured one's on the negative 12 volt rail, which I found a little concerning. Now one chip is directly across both rails, and it's this one right here. That's got plus and minus 12 volts going to it. So that chip may be bad, I don't know. But yeah, we'll just keep probing through. So the pin 4 is missing the VCO signal. So I'll trace that back. This is a piece of coax right here, which is going through this little stub, through the chassis. comes out on this side, and I can't see a wire on it. I've had a look around, there's no wire connected. I think the wire's come off. So the wire colours, I should make a note of this before I move on, in case another one falls off. So looks like we've got pink on the left pin, so the very end pin is pink. Next one's got the one which is missing. The next one over looks like purple, or maybe grey. Looks like dark, yeah, it's a grey. Next one over is an orange. The next one over is white. And the one after that is brown. Right, so it's pink, missing, grey, orange, white, brown. Now there's a yellow one here, so I think the one that's missing is a yellow. So I wonder if that's all that's wrong with this now, is I will need to get this module back out and just check that wire. Because like I say, I can't see it, it's really cramped in there though. And I'll reattach that wire, maybe that will change something. Maybe that's what's wrong, is that the signal is purely missing, and that's it. So we'll find out. Let's get this module out first. Again. Thankfully it's actually pretty easy to get this one out. This is supposed to be non-serviceable. So the service manual says that this is not repairable. Not user repairable or something like that. Non-user serviceable or something like that. I can't recall exactly the exact words, but basically I say you can't fix it if something goes wrong with it. And there's no information in the manual about the actual circuit. There's no, well, you've got block diagrams and descriptions, that's it. There's no circuit diagram for it to tell you how it actually works precisely. Which is a bit of an annoyance, but you know, can't do much about that. You can't go back to them 40 years later and say, hey, this isn't good enough. So you can guarantee that you wouldn't get much help. Because, well, for starting Marconi, I don't think they exist anymore, actually. So let's get this board out. That is a 6mm spanner, in case you need to know what that is. Now this is a bit tricky getting the board out. You've got to kind of position it so you can get it out without pulling on things too much. Just comes out. Okay, so there it is. And sure enough, another wire just came off, which is good reason that I've made a note of which ones I went to. Right. So it's probably come off when I was repairing it previously. So the pink wire is also just fallen off, and there's a yellow wire. So yeah, I think it's got this like tape here or something. So I think I'm going to take that off, because all it's actually doing is getting in the way, it's making all the wires get pulled. So I'm going to rip that out of there. Just want that gone. It's putting too much stress on the wires, I can't move individually. Get that out. Okay, so that's a bit better. Now it moves around a bit more freely. So yeah, there's the yellow wire, there's the pink wire, just there. So I'm going to reattach those, and then we'll put it back together and see if it changes anything. Hopefully that's what's wrong. I'll stick the pink one first, I think, because it's, well, maybe, no, I'll stick the yellow one first. That'll be easier to get onto. Okay. So let's put it back together. See if it works now. That might be all that's wrong with it. No, it's just spinning, it's not actually going in. Right. Oh, another wire's broken off. This time from this end. These wires are certainly fragile. I'll put that one back on afterwards. So these wires, in case I break another one off: white, orange, black, grey, brown, yellow, pink. I didn't have this much trouble getting it back in yesterday. Hopefully I haven't come back off the other end again. Still seem to be attached. Great. So I'll get those screws back in, then I'll reattach that wire there. Then we can give it another go. See if we've made any progress. I really hope so. So the fact I found a wire off is a bit of a relief. Oh God, don't drop underneath. Right, let's get these wires out of the way and reattach that white one. I mean, these did say it's not supposed to be user serviceable, so yeah, they probably didn't plan on this ever being messed around with. Certainly not 40 years after the fact when they first built it. Just got to reattach it onto there. Okay, back on. Let's power it up and see if we have any success. One little neat feature of this, which I've discovered, it's actually mentioned in the manual, is that you've got this weird bloody protrusion of the circuit board here. That's actually a built-in riser. So what you do, normally it sits in there like that with this joiner board here. Well, you can actually turn it like this and plug it straight into the motherboard. Like that. Ta-da! So that's a really nice little feature they put in there, building it in. Right, well, let's plug power in. You can see some lights, let's turn these off so you can see a bit better. Let's chuck a signal into it and see if we've got any luck. See if anything's changed. Still no signal. Yeah. Still no input signal. If I stick that in channel B instead and flick it over, then you'll see, yes, there is a signal there. Alright, so channel B is working fine, channel A still no good. Right, we'll keep working on it. You can go back to probing those signal lines now. When I first worked on this yesterday, I had issues with alignment slightly. The back panel was slightly bent, so I actually fixed that now already. So it should all line up nicely now. That screw there actually lines up with that slot and things like that, so it wasn't right previously. I'm not putting all the screws in because I'm only putting enough in to make sure it's got the correct earthing on the various traces. So one trace goes right up, so I put one screw there, there's a trace here, and those two there joined together. So I'm only putting in as much as I need to get the job done, to hold it in place, because obviously I keep in and out all the time. Right, let's do some probing around. Let's see if we've got anything different over here now. Got to be careful about this, because this is a power supply, stuff like that. I'm not actually sure if there's mains voltage on here. There probably is. I'm just assuming there is. It's the best way of doing it. Is to assume it's going to be live. Let's turn this big one here. Okay. Power on, channel A, and let's recheck them back all the way back through again from channel 12 back down. So, yep, so that's plus 5 volts there. Minus 12 volts there, correct, just in case there's any shorts or anything like that. I've got that 3.9 kilohertz waveform on that pin, that's right, and on there. Next pin's got nothing, so that's, as I say, it's 10, 9, 8's got nothing, 7 should have a square wave on there, which it does. Pin 6 should have the other waveform on it, which it does. That's actually synced to pins 9 and 10, so if you're using multiple channels on the scope, you can actually sync it on 9 and 10 and then see that waveform, and you should be able to see it frequency modulating, apparently. So that's 6, 5, nothing, 4. I now have a signal on channel on pin 4. Right, but what do I have? I have a DC offset frequency, which is oscillating. Yep. And that's oscillating between 30 or 40 megahertz or so. It's hard to see because it's oscillating. But that's the signal I'm expecting to see there. That's correct. Alright, so we've got some progress there. Now what's supposed to happen is when I put a signal in, it's supposed to change what it's doing. So it's, again, be careful when I'm leaning my hand. Pin 4, put a signal in. No difference. It's basically acting like there's no signal. That's the way it's behaving, is that there's no signal going into it. Yeah, because it's supposed to lock onto a VCO frequency or something. It's supposed to lock onto a frequency. And relative to the frequency that's going into it. And this is not happening. So this op amp here, it's a quad op amp. I probed around on that before and I was getting some kind of life. I really need to sort of change the camera angles the same so I can show you what I'm doing here. So that's giving me pulses. If I take that off and I've got a triangular wave instead. So that is responding to the fact that we've got a signal. Right? So there is something in here saying yes, there's a signal getting into it. And on this pin here, that's currently low, I think. That's low, and then it goes high when I take that off. Okay, so that's doing something. Probe into that pin. That is some kind of square wave. Feels like a square wave. I'm just going off the screen. Yep, it's a square wave. Take it off. Still a square wave, no difference. Check the inputs to that. That's not changing. That's a triangular, well, a ramp. Negative gain ramp. Take it off, still negative gain ramp, no difference. That pin there's nothing, still nothing. Nothing, still nothing. That's a triangle wave, still a triangle wave. So I'm not quite sure, because I don't have a circuit diagram for this module, it's a bit hard to actually figure out what's truly going on there. So at least I found another problem. The signals that are there all are acting as though there's no input signal onto this module. So the activation change switch on the front here, say between channel A and channel B, that's switching correctly, that's doing what it's supposed to do. All the signals we're seeing here now are as they should be from the manuals with no signal applied, with or without signal. So let's try applying a stronger signal now, just in case it's just really weak. So let's increase the signal level. Let's go 5 dBm, still no response. 11 dBm, still no response. It's supposed to be maximum of 13, so I'm sort of approaching the maximum limit of what you can actually take on the input. And let's just check these again, see if anything's changed over here. So pin 4 is still the same, it would appear. Yeah, that's still doing exactly the same thing, no difference. Pin 6 is still doing the same, no difference. 7, that's still doing that square wave with the same frequency, so there's nothing changing there. Alright, so regardless of the input level, everything's working exactly the same way, whether it's here or not. I know it's getting through to here, and I'm seeing response on the chip when there's a signal on there, so I know that is kind of working. But something's obviously blown in here somewhere, I just don't know what. I'm leaning towards this because that's across both rails, the two rails which had a problem. So maybe it's stressed that. It could be one of the other chips too. I mean, I could just replace all the chips and have done with it and see what happens. I might even have some of these in stock. Possibly, anyway, I have to check. So I thought I'd just record the scope waveform so you can see for reference what I'm talking about. Right, so the unit is that's on, and this is pin 1. So 12 volts there. Pin 2, nothing there. Pin 3, nothing there. Pin 4, see there's a DC offset and there is a waveform there, right? Albeit very small, it's there. And if I bring this out, you can see the oscillating waveform there. Okay. The frequency is jumping around here up to 40 megahertz and below. Right, so it's definitely looking correct. Right, I'm not sure about the DC offset part though. I didn't mention that in the manual, but it just showed the waveform. And the peak-to-peak waveform is only 500 and something, 600 millivolts maybe. Right, so it's not a very big VCO signal. Maybe there's a problem there, I don't know. So it's pin 5, it's got nothing on it. 6 has got this one, which is again an oscillating waveform, which is supposed to be synced to the VCO, and it looks like it's doing the same thing. Right, this is in kilohertz, but 5 volts. Alright, that's pin 7, which is that 54 millisecond pulse, well, square wave. Alright, pin 8, nothing there. There's pin 9, which is that waveform I was saying before. Okay, so that's the waveform getting there, and the same waveform on pin 10, also, but there's supposed to be a phase difference here. Pin 11, that is minus 12 volts, and pin 12 plus 5 volts, or thereabouts. Voltage measured on here is not 100% accurate. I mean, it's not perfect, but it's close. There you go. That's what you're actually seeing on the scope, and those are all the waveforms you should be seeing when it's got no input signal, which I currently don't have. But when I do put an input signal on, it doesn't change. Now the VCO one I'm not sure about, but that big DC offset there, I mean that frequency, the amplitude of the frequency there, and that big DC offset, I'm not sure those are right. I'm going to reread that part of the manual. That could be a symptom, but the fact that's basically on the outside of that module is not showing us receiving a signal. It should change states. That VCO line should go up, or should go high, or should go low, or something like that, depending on what waveform it's at the time or something. But it's not 100% clear, but I wish I had a circuit diagram for this module. So I just re-looked at that service manual in reference to that VCO signal on that pin 4 over there, and it actually does show the waveform, and it does show a ground reference. So you've got the 0 volt reference there, and then the VCO waveform, which does have a DC offset, but it shows a peak-to-peak voltage of 3 volts, with the lowest point being 1 volt above. Right, so it should be 1 volt to 4 volts. Right, 4 volt peak, 1 volt dip. So minimum maximum 4 volts, 1 volt. I'm not getting a 3 volt peak-to-peak signal. I'm getting 500 millivolts, so that is way off. Maybe that's related. That's probably the first thing I've actually seen coming out of that, which is wrong, apart from the fact it's not reacting to any input. So I think I need to try and trace back that yellow wire which comes up here, and look at this section of the circuitry here, and try and see what's going on. The other board looked perfect. I didn't see any faults in the other board when I took that one out. Well, I didn't take it out, I just took the cover off. All the channel antennas looked okay, everything looked fine. So I think everything I've got an issue with is on this side of the board. And yeah, it all ties into being in this area here, so we'll see. I mean, I did have a bad tantalum. Which one was it? That one's burnt. I think those two there were discoloured, was it? I think it's that one and this one here, something like that. Yeah, that one there, this one here, discoloured. So that chip could have been stressed. I don't know, it's coming into this area, so I'm going to have to try and trace the circuitry out here and figure out what's going on. But yeah, this is going to be tricky. So after much messing around with this stuff here, I've found that this section does actually work. I've twiddled these adjustments here, and I managed to get the actual frequency to display now. So I've actually got it displaying 2.4 gigahertz, which is above its rated, which is 2 gigahertz. So on this channel, I'm actually getting it run between 100 megahertz and 2.4 gigahertz. This channel will just about sense on. And that's alright, I suppose. Now, I also want to make a note of what these adjustments are. Now, I don't actually know what they're doing. This one seems to be adjusting frequency. There's a frequency on one of the wipers, so I don't know. They're all basically in the original positions, but basically I've just tweaked them very slightly. They're only just like, I've marked them all where they were, and then just adjust them and try different things to show them, see what's going on there. Maybe because this had already been unsealed by someone, maybe someone already twiddled those pots around, so I don't know. So I thought I'll do a reference here. Now this is adjusting a voltage. If I do to the, I'll try and show you what I'm going to there. There's a bit of lighting. So you've got these two pots here, the pot closest to the side at the furthest leg, alright? Fortunately I can't see it very well on this particular camera lens. So I'm getting 2.45 volts there. That seems to be about, that's like a nice point. 2.4 to 2.5 seems to be a bit of a sweet spot. It was 2.4 before I adjusted it, so I've changed it by 0.05 volts at that wiper. At that leg there. Well, it's not actually on the wiper, it's on the other end. If I measure the wiper, it's actually nothing there. Alright, so there's nothing on the wiper in there. The other pot, same leg, furthest one that way, 2.12 volts. 2.1 volts was about what it was when I started off. So almost no difference whatsoever from factory. But they're really fine adjustments. These work in conjunction with each other. I did assume originally that they should be like because one's a positive, one's a minus, one's positive and one's negative. Right, so that's plus 2.4 volts, and it's minus 2.1. Right? So I thought maybe they should be balanced, they should be exactly the same or something like that. I tried various settings and they didn't really match up. This one always has to be a larger value. So I'm not quite sure why that is. Maybe it's just a characteristic of this particular circuitry, I don't know, but that's what it seems to need. So that is, for reference, what they're set to. Right? 2.12 or minus 2.12 and plus 2.45 or so. Now this one here, this oscillator one, it varies a little bit, but 0.45 on that leg there. That's 0.21 on that leg there. Now this is actually an oscillator though, so on the scope it's oscillating. At least it's oscillating when I don't have an input signal and stuff like that. So, but that's the points I've got there, and that is now working. So this appears to be fixed. So I think that what happened originally is it's blown up, and it's changed the tolerances maybe very slightly on the circuitry. Maybe even, it may have been partially damaged, something, I don't know, but I probed around all these parts. This that chip there, it's a 74 S04, which is a hex inverter, and I've been checking that inputs and outputs all match up. That's all working fine. That's basically a transistor array. That's a CA3046, and that all checked out okay. So we've got a TL084CN and a TL081 CP, both op amps, right? Quad amp, single op amp. They'll checked out as well. So I couldn't actually fault any componentry. I went around, did individual testing of all the resistors to make sure they're all okay. The measuring within range of the markings. All checked out okay. Checked all the diodes, checked okay. Checked the resistor, checked okay. Can't fault a single component on the board. The inductors all check out. So I was thinking, well, I've checked all the parts. Everything seems to be working correctly. I made a probing mistake. When I was probing this pin 4 on this header over here, I was only getting a relatively low waveform on there. What it turned out was is that I had my probe set to times 1 instead of times 10, so I was loading it down, the basic thing. So I've gone to times 10 now. I'm actually getting the right kind of signal levels in that pin 4. So that all checks out now. But yeah, it's been a interesting thing. So this is now fixed. It works. If I spin this around, so I'm injecting currently a 2.4 gigahertz signal. There you go, 2.4 gigahertz. Obviously it's upside down, but you know, as Dave will say, all the electrons will fall out. There you go. Right, 2.4 gigahertz, and that's working. Alright, so it's not too bad at all. I can go down to 100 megahertz, and it will still work. At least it was just now. There we go, 100 megahertz. So right on the threshold of working at 100 megahertz. It's rated to 200 megahertz is there. Alright. RF level is currently set to minus 12 dBm, which is what it's kind of rated at as this large threshold. So yeah, I mean it works. If I drop the dB level down, not down, not up, so it cuts out there, which is, let's get the threshold there at 200 megahertz. There, that's minus 19 dBm is that threshold. If I go in frequency to 2 gigahertz, it's the same output level. Let's find that threshold level there, but it reads accurately. It's about there, oh, almost, slightly more. That's about minus 17 dBm. Don't forget, I'm going to have loss in the cables and stuff like that, because these are, not particularly high quality cables. So there's going to be a little bit of loss in there, and because the shield is not on the cover and that thing, and it's that sort of stuff, so it's going to be affected a little bit. It's jumping around slightly still. It's minus 16 then. Okay, so but it's still within what it says is the threshold, which is minus 12. Minus 12 should be a stable reading, so it's performing as well as it should do, and it's covering the whole range, or more than the whole range, and it's all working. So I'm happy with that. Now I just need to actually check this side again. This might measure 2 gigahertz, so let's go down to 200 megahertz. So we go 200 megahertz on that side. Alright, so that's all fine, and thresholds Let's see where that one goes down to. It's currently minus 16. See where it drops out. I haven't actually tried this yet. Reliably, it's about minus 21. Minus 21 dB at 200 megahertz on that one. Not sure what we'll actually go up to. Let's try 250 megahertz. Oh. I won't do 250 on this side, maybe if I increase the input level. Let's go minus 12, which is its spec. Well, it's what's mentioned in the manual. No, I won't do it. So that's fine, it's not supposed to do that. Just want to see if we can do it, really. 210 megahertz, let's do it now. So yeah, it's fine. 1 megahertz. There we go. Scroll down a bit. And okay, 100. What's the last frequency I'm doing my generator here? I'm not sure actually. 0.1 megahertz. That's 100 kilohertz. Yeah. My lowest I can do is 100 kilohertz on this generator. So yeah, that's 1 megahertz right now. So push the wrong button, as I tend to do. It's working fine. Absolutely fine. So I'm happy with that. It's that side again. Right down, should be able to measure all the way down there. Long gate time though. There you go. So it's working fine. I'm happy with it. So I'm putting it back together now. That's a fix. Thanks for watching. Hope you enjoyed it.